Hello, I'm going to talk about T217, the second half, and also about TMA03, but I'm also going to very briefly at the end cover Block 5 and and TMA04, only very, very briefly. I've tried numerous times to record this in Adobe Connect, and I've had problems on each occasion, so I'm trying this rather different approach of pre-recording narration to the PowerPoint, and I hope that it works for you. So, have you had time to reflect on TMA02 and what you've learned so far? I'm sure you probably encountered some challenges because it was a really massive TMA, but hopefully you learnt quite a bit on the way as well, and it's helped you to integrate some of the ideas that you've already encountered from the module. So the first half of the module was very much about thinking about how you are going to design for users and also about generating ideas. In this latter half of the module, we really get down to the detail of designing. So we have block 4 and 5, which are both about different aspects of detail. Block 4 is about configuration and layout and embodiment, and block 5 is about materials and manufacture. So by the time you've finished the module, you really ought to be able to understand the complex decisions that designers make and to be able to think about those decisions when you're designing for yourself. I'm going to run through some of the key points of Block 4. The main focus of Block 4 is on layout design, or an alternative term for it is called design embodiment. Personally, I like the term design embodiment better because I think it sounds more all-embracing. It's very easy to mistake that layout design is just about how components are going to be arranged. And although that is obviously part of it, it's also about how they're going to be connected and what they'll be made from and what they will look like. I'm going to go through each of those aspects separately. So, when it comes to exploring arrangements, there's a really nice example in the block. Mark Saunders, who is a designer and wanted to design a bicycle that could be taken on a commute. So his primary generator, his main idea was that rather than it folding up into a suitcase-like arrangement like a Brompton does, that it would be something that would be long and thin, more like a buggy when it's folded. So on the left-hand side, what you can see are some of the explorations that he did of what the possible configurations of the different components of the bicycle might be. And they're really, really simple drawings, aren't they? But if you look carefully, you'll see the little letters that denote where he's put the brake, where he's put the seat, where he's put the handlebars. Obviously the wheels, they're fairly self-evident, but he's still given them a letter, and so on. So in these drawings, he's basically thinking, and he's thinking with his pen, now what if I connected this bit of the frame to that bit? What if I put the seat here rather than there? Where shall I put the brakes? Each one of those is representing a different possible configuration. And I hope that that gives you some hope that when you're asked to explore configurations in the TMA, that really it doesn't have to be really complicated. Each one of those has got something that makes it a unique idea, that makes it different from the idea next to it or above it. And on the right hand side, what you can see is his final patent design, and the idea that he finally arrived at, the configuration. And you can see that that's really quite detailed, and being a patent drawing, it has lots of numbers all over it, which correspond to things that he has to describe in the patent about the unique properties of his particular design. So in the process of layout design, this is a process that, a bit like the ideas generation that you've done, it's a process that goes from divergent to convergent. You start out with identifying the main parts and exploring a multitude of potential arrangements, just like we've just seen in Mark Sanders' drawing. But then you start honing down. You decide the arrangement that you want, and you start defining what the connections are going to be. And then you hone down even more to really lock down what the shape is going to be, what materials you're going to use, and how it's going to look overall. So this is yet another part of the divergence and convergence that takes place in the design process. So the second aspect of layout design is connections. And as you will see in book 4, a guy called Chernikov in the 1920s drew up this rather nice list of potential forms of connection and the rather splendid Russian 1920s illustrations that go with them. And he describes these potential connections as mounting, embracing, interlacing, penetrating, clamping, and coupling. Now, this isn't an exhaustive list. Other people have come up with other ways to describe even the same sorts of things. But I think if you take this as a base point, it at least puts into your mind the different ways in which you can join things together. And that's really important. And how you do that is going to depend a lot on what your materials are, and the kind of look that you're going for as well. That it's all related to one another. But this is a really handy kind of little list of potential ways in which things can connect. So in the block, you will also encounter the notion of irregular or regular order. On the right-hand side, you can see the Bauhaus, which is a very regular shaped building. It's built on the repetition of patterns, the repeating of the same shape of a window frame, the repeating of the placement of the windows in the building, and also within the typeface, which is almost symmetrical, apart from the letters, which are not symmetrical to start with. That contrasts quite well with the photo on the left-hand side, which is of the Guggenheim Bilbao, which is a beautifully irregular building, and that's really its charm, is that it is something that is not expected. It diverges from what one might imagine of a building to become something really quite fantastic. In my face-to-face day school, I challenged people to build something which had regular order. I also challenged them to build something that had irregular order. We had lots of fun with Lego. Another important thing to be aware of in layout design is mechanisms. If there are going to be moving parts in the design that you're working on, then you need to think about what the mechanisms for those movements are going to be. So there's a few different kinds that are shown in the book. We've got piston and crank, rack and pinion, there's a cam, there's gearing, and then there's a drive chain. Obviously, there are other forms of, not exactly mechanism, but functions which require power, such as electronics and so on. And whatever moving parts you're choosing, or the kinds of electronics that you wish to incorporate, it's going to affect the configuration of any design that you make. And the configuration will affect the parts that you can incorporate. So really important to think through the detail of how am I going to make this work. Another key thing that you have to understand really for the TMA is the notion of function. Now, function isn't just about what a product should do. Designers do think about essential and secondary functions, but we're defining function in a much broader way than simply what it does technically. Of course, that is part of it, but its function is also about how things are intended to be used and the function that they're going to have for the user. They're about the sustainability of a product and the environmental impact that thing has. They're also about aesthetics and how a thing looks and feels. and something called identity, which is really about how a thing conveys its uniqueness. So if you think, for example, of some famous brands such as the Dyson, Dyson uses particular colours and particular shapes to convey that a product is a Dyson. You probably everybody could go into a shop and amongst the vacuum cleaners could pick one of those out. So when we're thinking about component design, we need to think about several different kinds of properties of parts. So designing components means thinking about shape, size, strength, surface finish, and colour. I'm going to go through each one of those in turn. So when we're thinking about shape, one of the things that's worth knowing is that it's very possible to make quite complex shapes by basically joining basic geometric shapes such as circles and rectangles and triangles and lines, or if we're talking in 3D, they're 3D equivalents. Think about the negative spaces around the shape that you want. Obviously, when you sketch something out in rough, that gives you an opportunity to think about how this might be achieved. So, for example, if you look at the shape that's on the right-hand side here, by adding two little circles at the kind of waist of the two and the join of the two bigger circles, we could, if we sketch around the outside of those two little circles where they're touching, we could create something that's like a guitar shape, and it would be properly proportioned and as correct rather than a difficult curve to draw. So you'll find in the book there's many examples of the ways in which combining shapes can be used to make for a more complex shape. So also at this level of detailed design, it's really important that your drawings have dimensions and that sizes are properly specified. If you look at chapter 4 of block 4, you'll see examples of how to specify for different shapes, because obviously a complicated shape is going to have to be specified and shown in different ways to something that's just a simple rectangle. It's also really important to know how components will behave. Components can be strong in many different ways. They can be tough, they can be resilient, they can be hard, they can be dense, or you might need them to be elastic and flexible. And achieving that is going to depend on the materials that you use and also the shape of the component. If you're wanting to make really good design decisions, you need to anticipate what the forces are going to be that will act on the components and to think about what properties then they need, in which respects they need to be strong or tough, or do they behave well under compression or when in tension. Obviously in a real world situation, one would attempt to test those things. We're not expecting you to do that in your own homes, but trying to think through what the forces are that will act on components is really, really helpful. If you were surprised to see colour on the list of properties of parts, it's really not just about aesthetics. It also can be absolutely crucial when you're trying to identify different elements of a design, and sometimes that can be really serious. You need to have wiring that can be easily recognised, for example, for the live wire and the earth and so on. And knowing how colours work with one another can also be very helpful when designing. You don't want to make something one part that is less important stand out more than another, and yet by putting two colours together, that could potentially happen. So in the book you'll see there's information about various aspects of colour, such as hue, lightness and saturation, and it's a really important aspect to think about, not just in terms of how nice the thing's going to be at the end of the day. Surface finish is also important. It protects components, but it's also important for the look and feel of a designed object. So you've got a highly polished surface that's going to look and feel very different to a rough textured one, and it's going to perform differently. For example, in the day school, I looked at some old electric toothbrushes with my students, and they obviously have quite a highly polished surface. The only bits that are less polished are where the switches are. The polish actually acts as a way to help to repel water and toothpaste and all the other gunk that you get when you brush your teeth. But the one place that it'll congregate, if at all, is going to be around the switches, which tend to be made of things like silicone. In an outdoor environment, a rough textured finish might be absolutely what's wanted in order to make something rugged, and also to convey a sense of the outdoors. So choosing your surface finish is important. So the best way really to start thinking about all of these things is to look at objects. Look at an object, think about what its function is, and remember that's not just function in terms of technical, but in terms of usability, in terms of sustainability, in terms of aesthetics and identity. Think about what its component parts are and how are they arranged. Are there any joins or connections? And if so, what kind of connections are they? And if there are any moving parts, what kind of mechanisms are used? What are the properties of the components? What shape and size and strength and surface finish and colour do they have? And drawing, dimension drawings of an object is really good practice. It's something that you will find yourself doing in the exam. Maybe not a fully, properly dimension drawing, but being able to look at an image and to replicate it is something that you're likely to have to do. So the more practice that you can get in, they won't be hugely complex objects, but worth trying, even if you spend all your time just drawing your teacup and your microphone and things like that. So, having taken you on a lightning tour of book 4, I'm now going to talk about the TMA. Now, this is, I think, quite an interesting TMA. You're basically going to do an IKEA hack, and that's discussed, and there are examples on the website materials that support the books. What we're asking you to do is to develop one project idea for home or office, and to develop that into a layout design, basically by repurposing and reconfiguring components from existing IKEA products. Now, I want to stress that it is only one project idea that you have to take all the way through. Sometimes I know people get rather carried away and want to present a lot of them. You're going to get an opportunity to explore different configurations, but all you need to do is to present one project idea. And we give you a choice of potential projects that you could design for. So one of those is a small table, such as a coffee table or a bedside table or a side table. Another is a storage space for a small bedroom. And the third is a shelf space for a young person's room. But because sometimes you want to get really creative and do something different, we also will allow you to do any other idea for a design product that is for home or office use. And what you're going to do is select one of those layout projects and then develop your design specification. So you're going to say a little bit more about what your intentions are. So if it's a coffee table, it might be a coffee table with additional storage space, or a coffee table with built-in coasters, or that, whatever you need to be clear in your design specification how you're going to kind of make it your own, really. And we make some suggestions about the IKEA products that you can use, but you can actually use any product that appears on the IKEA website. And if you want to, you can also include some other found objects, such as a tree branch or pebbles or rolled up paper or something. Do remember, though, that you are going to be drawing this, so you might want to bear that in mind and not make life too complex for yourself. So the TMA is in 4 sections. The first section, which is worth 25 marks and gives you a 500-word allowance, it asks you to introduce your selected project idea, saying what its desired characteristics and requirements and context of use are. So that's really the specification, just trying to say more about what you wish to do with it. Now, it's possible that you might find that you're not absolutely clear when you start out. It might be that by doing things with the components that you hit on ideas. So that you might be writing that introduction retrospectively. That's fine, as long as you do give some detail about what the characteristics are and its requirements and so on. And then in this first section, you're going to analyse the layout of IKEA products that you've identified as possible candidates for your hack. So you need to reflect on at least 2 of the 4 aspects of layout design. So just to remind you, that's components, arrangements, connection, and form. So you don't have to look at all 4 of those, but you do need to look in depth at 2 of those, and that analysis should lead you to have some initial thoughts about why or how you might use certain products to do your specific project idea. And absolutely critical that you include annotated sketches or photographs to support your layout analysis. So in looking at the wording for section 1, I thought it could perhaps be a tiny bit clearer. So here's the interpreted version. Basically, in this section, you're going to say what you've chosen, what you want it to do, and where it will be used. And then you're going to look at your 2 products and identify the different aspects of their layout design, component, arrangement, connection, and form. And then you're going to put some ideas down about how those components could be used in your project that have been prompted by looking at the layouts. And you're going to include your sketches and photographs. If you look, there's a guidance section on this part of the TMA, and it gives you some ideas about things that you should be looking at in your layout analysis. So do make sure to make use of that when you're doing the TMA. So in this second section, you're being asked to present 4 or 5 alternative configurations. And it asks you to use the approaches for generating those configurations that are described in the block in section 2.2. So there are 3 possible strategies that you might use. You could identify and use design configurations that you've seen in other products. You might try variations on the existing configuration by, for example, using more components or fewer components and arranging them differently. And you might use some of the tools such as grids, growth processes, or symmetry breaking rules to try and explore some alternative arrangements of components. If you're not clear, particularly that final one, you really need to read the block to understand exactly what those tools are. But it's basically a way of exploring geometry by trying new ways of configuring things that are not exactly as you might expect them to be. So as it says, symmetry breaking, so making something that is irregular rather than regular in order. Do have a look at the book if you're intrigued and think that might be something you would want to do. But think back to Mark Sanders' drawings that he made for exploring the way in which the strider might be configured. You do need to do a little bit more than that, and the next slide will show you what exactly you have to present. But that kind of rough sketch thinking is a very good way to start getting into the process. So, as I've just said, you might use rough sketches in order to get into the thinking about the possible alternative design configurations, but what you actually need to present here is orthographic sketches and drawings. You can include perspective drawings as well if you want to, although personally I think you don't need to do that. You don't need to give precise dimensions to your components and the overall design at the moment, but you do need to make sure that they're roughly in proportion. So there are ways that you can do that, like using a grid with tracing paper over it, or just simply using a ruler to check the sizes and dimensions of the components and the design. You're asked to give an indication of scale on each of your sketches, and you either do that or you include a couple of dimensions to indicate scale. If you're designing something like the table or a storage thing, it's very likely that the kind of scale you're going to be using, if you're drawing on A4 paper, is going to be 1:5. But do try to get that as accurate as possible, because it's a really good way of showing that you're understanding the detail. You can, if you would rather than hand drawing, if you're somebody who's confident with SketchUp or other CAD software, you can use that. But remember, these are orthographic drawings that you're presenting at this stage, so you don't need to go the full 3D experience. And each of your sketches or drawings should be accompanied by a very short description which explains the approach that you use to generate the configurations. And this is where you're going to refer back to section 2.2 of book 4. And the content of this section is all linked back to assessment activity 4.2. So again, I thought that it was quite long, the way in which it was expressed in the TMA. So this is a kind of shortened version of what you need to do, just to try and help you to see the bones of it more clearly. So basically presenting 4 or 5 alternative configurations using the approaches for generating configurations that are described in the block. And I've just been through those, using existing design configurations, changing the number of components or the way they fit together, or using one of the methods such as grids or growth processes or symmetry breaking to try and explore some rather different arrangements. And again, a simplified version of section 2. Definitely use orthographic drawings, but include perspective ones if you really want to. You don't need to have precise dimensions, but they should definitely be roughly in proportion, and there are ways in which you can achieve that. And then make sure that you've given the scale or included dimensions to indicate scale. Draw by hand unless you really want to use some kind of CAD software, and make sure that you explain the approach you took to generating configurations, and make sure that you refer back to the block. So in the third section of this TMA, you're going to evaluate the configurations that you've presented in section 2, and you're going to select one of them to take further. You're going to be doing your evaluation and discussing the comparative advantages and disadvantages of each of your designs on the basis of at least 2 functions. Now, if you think back to what I said about block 4, functions are defined not just as technical function, but also as usability, aesthetics, sustainability, and identity. So you're asked to choose 2 of these different functions in order to compare and contrast the different designs that you've generated. I would suggest choosing 2 that are a little bit different. So you might do, for example, technical function and usability, or aesthetics and usability. I'd steer clear of aesthetics and identity because they're quite similar in some respects. They are different, but it can be a bit subtle. So I think probably I would, if I were you, I would go for the other aspects. Sustainability is a good one to discuss, certainly. So you'll find that the 5 functions are discussed in Chapter 2, Section 2.2.2, and also in Chapter 3 of the book. And use that to help you to truly understand what the subtleties of each of those functions are. And make sure that your evaluation includes annotated sketches that support your arguments and the selection that you choose. So the final section of the TMA is where you present your final design configuration. So you're asked to either do hand or computer-generated drawings that, as it says, specify the geometry of your selected design configurations. That's quite a posh way of just saying how the thing fits together, really. So you need to present at least 3 different views of your design using orthographic drawings. It can be 2 orthographics and 1 section. But they should be to an appropriate scale and they should be dimensioned. You also need to submit 1 perspective drawing, and everything, the perspective drawing doesn't need the dimensions, but all of the orthographic drawings do. You can see more about this in Assessment Activity 4.4. So just to give the shortened version, present at least 3 different views of your design using orthographic drawings, drawn to the appropriate scale and showing the precise dimensions, and submit 1 perspective drawing. That's there's no writing involved in this final section. So what are the kind of things that are going to gain you marks on the TMA? Well, making sure that you use and refer to the material in the block is really important. Lots of people use the material but forget to actually reference it. So try to do that. It's really good practice to get into, especially when you move on to the 3rd level of study. It's really expected at that point. Make sure that your work is really well illustrated throughout, and think carefully about all of the details about how things are going to be joined, how they're going to do the job, what the sizes and shapes are. It's that the devil in this situation is definitely in the detail, and it's that attention to detail that's going to gain you points. And also try to make your presentation as coherent as possible to help it as a communication, so that there's a flow from one section to the other. So having talked about the TMA, I thought I'd say a little bit about Block 5 and its related TMA, just so that you know where you're aiming, because it helps to understand why TMA03 is how it is and what it's taking you towards. So Block 5 is about design for making, and its focus is very much on materials and production processes. It looks at how designs can be optimised for manufacturing, and it also looks at sustainable design and the challenges for designers. And there's also some stuff about 3D printing and CAD, because they're of increasing importance in the design industry. So block 5 is really a natural follow-on from block 4. It's really about the next step after layout design, because designs often end up having to be changed at the manufacturing stage because of the constraints of the production process, and the knowledge of production engineers is really critical in deciding small changes that might need to be made because, for example, the tolerances can't be achieved, or it can't be moulded in that way, or whatever. The more that you know about materials and processes, the more your designs will be manufacturable, which is why we end on design for making. So here's an example from the book of a diagram that's basically put together in order to sum up the territory that's covered by the CES database when it comes to production processes. And you'll see that there are three key forms of production process: shaping, joining, and surface treatment. Now those will all seem a bit familiar probably. From block 4 we talked about shape and about connection, and also about surface finish. So you'll see that it'll go into more detail, and each one of these things coming off the diagram is basically something that's discussed in the CES database. And if, like me, you're a Mac user and you can't use the CES database, knowing that these different processes exist, and this diagram hopefully will help you to look those things up, to find things that are appropriate for the kinds of process that you need. And just to briefly tell you about TMA04, because this is where you're headed in terms of the final piece of work on the module. The final TMA is a design project that really brings all of the knowledge together from throughout the module, and it asks you to design something for a national park. And you're given 4 themes to choose from: refreshment, recycling, playful engagement, and inclusive design. So there's lots of scope for you to choose something that appeals to you. So that final TMA will be using skills that you've developed from throughout the module. So you'll be doing user research, you'll be generating a concept design, you'll be working that up into a layout design, and then you'll be thinking about the materials and the manufacture to put together a final design proposal. Obviously, there's going to be tutorials on TMA04 nearer the time, but everything that you do for TMA03 helps to get you thinking about detailed design and bringing your learning so far together. So it's part of a whole continuum. So that's it. If you have any questions, I'm sure that your tutor will be able to help you. If you're one of my tutees, I'm always happy to be contacted if you need some more detail or you're not quite sure about something. Good luck, and enjoy doing this next TMA.